In this video, we will discuss solving right triangles using the sine, cosine, and tangent functions. If we do not know all the side lengths and angles of a triangle, we may be asked to solve the triangle. Solving a triangle is the process of finding the unknown sides and angles. To do this, we manipulate formulas and use other algebraic principles depending on what information is given and what information needs to be found. Using the relationship sine theta equals opposite over hypotenuse, we can find parts of right triangles when we know any two parts that involve the sine function, one acute angle, the side opposite the known acute angle, and the hypotenuse. Use the sine function to solve a right triangle. 1. Two of these three parts of a right triangle must be known, one acute angle, the side opposite the known acute angle, and the hypotenuse. 2. Substitute the two known values into the ratio sine theta equals opposite over hypotenuse. 3. Solve for the unknown part. For example, find angle A to the nearest tenth of a degree if A equals 7 and C equals 21. The two known values are the side opposite A and the hypotenuse. So we use the sine function for the acute angle A. Sine A equals opposite over hypotenuse, which is 7 over 21, or 0.333 repeating. Clearly, sine A equals 1/3, and sine inverse 1/3 is 19.47122.063. So A is about 19.5 degrees. Find side A if angle A is 53.5 degrees and C is 15 meters. We are given angle A and the hypotenuse and are asked to find the measure of the side opposite angle A, so we use the sine function. Sine A equals opposite over hypotenuse. So sine 53.5 equals A over 15. That's 0.8038568.606 is equal to A over 15. So A equals 15 times 0.8038568.606. So A is 12.05785291, or about 12.06 meters. Find the hypotenuse of a right triangle RST if angle R is 32 degrees and R is 25 feet. We are given an acute angle and the side opposite the angle and are asked to find the hypotenuse. So we use the sine function. In this case, the hypotenuse is side T. Sine R is equal to the opposite over the hypotenuse. So sine 32 degrees is 25 over T, which means T times sine 32 is 25. So T is equal to 25 over sine 32, which is 47.1769987, or about 47.18 feet. Solve triangle DEF, where F is the right angle, D equals 32.5 degrees, and E is 24 inches. We start by finding angle E since we already know that F is 90 degrees and D is 32.5 degrees. This means that E is 90 degrees minus 32.5 degrees, or 57.5 degrees. Next, we find the hypotenuse F using the procedure we did before. Since sine of 57.5 degrees equals 24 over F, F equals 24 over sine 57.5, which is about 28.46 inches. Finally, we have a couple of options to find side D. We could use the Pythagorean theorem since we know the lengths of the other two sides, but because this is a section on trigonometry, we will use the length of the hypotenuse and angle D. Since sine 32.5 degrees is equal to D over 28.46, D equals 28.46 times sine 32.5, which is about 15.29 inches. Use the cosine function to find unknown parts of a right triangle. Two of these three parts of a right triangle must be known, one acute angle, the side adjacent to the known acute angle, and the hypotenuse. Note that this means that if you have an acute angle and the hypotenuse, you can find either of the legs of the triangle, since the same parts were possibilities for using the sine. And substitute two known values into the ratio cosine of theta equals adjacent over hypotenuse, and solve for the unknown part. For example, find the included angle of a right triangle that has a hypotenuse of length 3.6 feet and adjacent side of length 1.9 feet. We are given the hypotenuse and the side adjacent to the angle, so we use the cosine function to find the desired angle. The cosine of A is equal to the adjacent side over the hypotenuse, which is equal to 1.9 over 3.6. So A is equal to inverse cosine of 1.9 over 3.6, which is 58.14456918, or 58.1 degrees approximately. Find the hypotenuse C of a right triangle that has an acute angle of 55 degrees and adjacent side of length 15 meters. The cosine function is the most efficient function to use because we are finding the hypotenuse and given an acute angle and its adjacent side. In the second step, I rearrange the cosine ratio to solve for the hypotenuse. I'll do that a lot. So cosine theta is equal to adjacent over hypotenuse, which means that the hypotenuse is equal to the adjacent side over the cosine of theta. So C equals 15 over cosine of 55 degrees, which is 26.15170.193, or about 26.15 meters. Use the tangent function to find unknown parts of a right triangle. Two of these three parts of a right triangle must be known: one acute angle, the side opposite the known acute angle, and the side adjacent to the known acute angle. We substitute two known values in the ratio tan theta equals opposite over adjacent and solve for the unknown part. Find angle A of a right triangle that has an opposite length of 14 meters and an adjacent side of length 16 meters. We are looking for an angle, and we are given the side opposite and the side adjacent to the angle, so we use the tangent function. The tangent of A is equal to the opposite side over the adjacent side, which is equal to 14 over 16. So A is equal to the inverse tangent of 14 over 16, which is about 41.2 degrees. To select the most direct method for solving a right triangle, where possible, choose the function that uses given parts rather than unknown parts that must be calculated. And where possible, choose the function that gives the desired parts directly rather than needing to find other parts first. Given the triangle below, find side C to 4 significant digits and angle A to the nearest tenth of a degree. The most direct way of finding C is to use the Pythagorean theorem. The two legs of the right triangle are given, so C is equal to the square root of A squared plus B squared, which is equal to 6 squared plus the square root of 6 squared plus 9 squared, which is the square root of 36 plus 81, which is the square root of 117, which is about 10.82 rounded to 4 significant digits. Use the tangent function to find angle A. The tangent of A is equal to the opposite side over the adjacent side, so A is equal to the inverse tangent of 6 over 9, which is the inverse tangent of 2/3. That is about 33.7 degrees. In solving technical problems, it's a good idea to draw diagrams or pictures to visualize the various relationships. To solve a problem using trigonometric functions, first determine the given parts and the unknown part or parts, then identify the trigonometric function that relates the given and unknown parts. Use this function and the given information to find the missing information. A jet takes off at a 30-degree angle. If the runway from takeoff is 875 feet long, find the altitude of the airplane as it flies over the end of the runway. We are given an acute angle of a right triangle and its adjacent side. We want to find the opposite side, so we use the tangent of the angle. Here, theta equals 30 degrees and B equals 875 feet. So tangent of 30 degrees equals A over 875, which means A equals 875 times tangent of 30 degrees, which is about 505.2. The plane's height is 505.2 feet as it passes over the end of the runway. Many right triangle applications use the terminology angle of elevation and angle of depression or declination. I will use depression over declination. The angle of elevation is generally used when we are looking up at an object. We use the angle of depression to describe the location of an object below our eye level. Both angles are formed by a line of sight and a horizontal line from the point of sight. A stretch of roadway drops 30 feet for every 300 feet of road. Find the angle of depression of the road. We are looking for the angle of depression theta, and we are given the opposite side, 30 feet, and hypotenuse, 300 feet of a right triangle. So we use the sine function. Sine of theta is 30 over 300, which is 1/10, or 0.1. So theta equals the inverse sine of 0.1, which is 5.73917, 0.477 degrees. The angle of depression of the road is 5.7 degrees when rounded to the nearest tenth of a degree. Find the angle a rafter makes with a joist of a house if the rise is 12 feet and the span is 30 feet. Also find the length of the rafter. The span is twice the distance from the outside end to the center point of the joist. The horizontal leg of the right triangle formed is 1/2 of the length of the joist, or 15 feet. The vertical leg is 12 feet. Because the legs of a right triangle are given, the tangent function is used. Find theta. Theta equals tan inverse of 12 over 15, which is tan inverse of 4/5, which is equal to 38.65980.825, or about 38.7 degrees. To find the length of the rafter, the hypotenuse of the triangle, we use the Pythagorean theorem. C is equal to the square root of a squared plus b squared, which is equal to the square root of 12 squared plus 15 squared, which is the square root of 144 plus 225, which is the square root of 369, which is about 19.21 feet. The angle the rafter makes with the joist is 38.7 degrees, and the rafter is 19.21 feet long.